actually lock in. I don't like taking breaks when I'm doing work. So I also can't work for super long when it's close to night because I get tired. So the only option is to start earlier. So start straight after work, or on weekends start in the morning. So this will be 6 hours straight. Okay, back to logical operators. I need music. It's too damn quiet this morning. Is this any good? How about this? Maybe these little pixel things are good. I need something more upbeat. Like, maybe? Fuck. I don't need rest music, man. I need, like, fuck. What is this? These recommendations are weird. Fuck. Just straight music is never good. What about, let's do tavern music. That'll work. As long as it's not heavy music. It's just straight music. Taverns don't sound like that, bro. Excuse me. That's better. Okay. Trying to find the most comfortable spot for the arms. So a little lower. Trying to find a spot that I could just fully lock in for 6 hours real quick, instead of being all like hunched over. So, gotta actually use this chair and get my money's worth. Okay, so we want to use or and the logical or and the logical and then maybe the not. It's the AC. Okay, we'll just do. I'm just gonna initialize 2 integers, and then put a literal integer, and then just do an or. Yeah. That way we can print true or false. And we'll do, or oops, we'll do a third. And Z is 3. So it's taking, the problem is this equivalency is happening after insertion. So I actually need to do this. Oh, I think I can just do that. Oh, that's nice. And that works. And then, I mean, I imagine, maybe it makes sense to just parenthesize the whole thing. That way it's print true or false, not 0 or 1. And output this whole evaluated guy. Instead of assuming that the logical or will happen before insertion. Because otherwise it might, it'll insert this, and then it'll be whatever this evaluates to, which is probably this or this, and then it's just weird. Okay, so it's true, but if we do and, it's false. Yeah. Excuse me. Ugh. Fucking allergies kicked in really bad this morning. Okay, and then what else could we do? The not operator. Yeah. And then we could do not this and this, but then we'd do the whole thing in parentheses again. Because I don't, well, not, no, we know that not has really high precedence, so this should actually be fine. So this would be true because Z and X are different, so this is false. This is true, which means this and this. One of these is false, so this returns false, which means not false is true. Okay. Oh yeah, like variables. So we could do this with user input, which will be cooler. Excuse me. So we'll do. No. Oh. Should be a little lower, I think. Just like that. There we go. That's pretty good. It's probably easier this way. So we'll just do an X. And then Y, same thing. Oops. And then what do we do? Let's not even do Y. Okay. So this is I mean, this can be a const expression. Yeah. Oops. Didn't give it a type. Cool. Alright, so we've acquired this. Oops. Cool. And then and actually we'll just do oh, oops. Alright, now we'll get another function. Mm. I mean, it's technically known, so I'll find out if I can do this. Oh, we didn't even say the fucking type. Const int. Mm. Oh, it's because we acquired it here. We can't acquire it in here, so I think this can just be, this has to be an int. It could be a constant though, I think. So this bool is fine because we're just returning a const expression bool. And upon compilation, we know that this is 0, which means we can pass him. Everything is known on compilation. We could say... No, I guess he can't be because... Well, couldn't he? No, because this guy was created in here, so I don't think we can. But he could be const, probably. Because he can't be changed, he's just initialized, and then from that he can't be changed. So we'll say 20, it's not. 19, it is. 10, it's not. 11, it is. Okay. So, saying we have this integer. And then we're acquiring one. Yep. Ow. And we're changing him so he can't be const or const expression. So, this boolean though we can, because this value is known and not changed here. It's just that it can't be const expression. This can though. And the reason why is because why we're implicitly converting to a const expression bool. Like I think it'll have an issue here. Yeah, we can't even have that, I forgot. So that's fine. Same thing. Okay, still works. So it gets passed to this const, so it gets converted Well, in this case, it already is a const, which is fine. The point is that this value is usable. It's not a const expression variable, but it is a const integral variable, which means it can be used within a const expression. Okay. Then if we change this to be or, is it greater than the min or less than the max? So if we did 1,000, it's greater than the min. And if we do 1, it's less than the max, but it's not greater than the min. Okay. I want to be able to just sit back and be here. But I keep leaning to the side, man. It's probably why occasionally my back will just feel kind of funky. I don't have back pain anymore, but like occasionally it's just kind of weird. I need to just, it's like I'm using my spine to hold myself here. I'm like concentrating it on one point and it's never backwards or forwards. So I'm trying to fix that. Hmm. Yep. Oh, yeah, true. Oh, gotta go to the bathroom. That took way too long. Okay. Oh, my right leg is strained. It's like sore on the inside, but not sore. It's just like it's real tight. Okay, yeah. So logical OR is true if either of its operands are true. The logical AND operator returns true only if both operands are true. Hmm. Okay, let's do that. So a conditional where I want it to execute only if multiple things are true. Okay, so we'll get string as well. And string view. Maybe not string view just yet. Maybe we'll do that. Yeah. Just expand the repertoire. Okay, so we'll do. Fuck, I can't say that. I could do that though. Yeah. Yep. Oops. Actually, no parameters. Duh. I'm only doing it once. It's honestly not even that big of a deal. Yeah. Okay, just in case we entered anything before, we're using getLine to get a whole line, including any spaces. I mean, I guess we don't really need to, but we want to, because that's how we do it for strings. We're not going to do... We could do it as a character. Like, what would happen if I just did it as a character? If we just said... Character input, RPG class. What if I just did that? And we said... Paladin. Boom. Okay, so that works. What if we did... I think that's fine. I mean, if it's only one word, it feels like this is okay. Let me see. Let's go check to see if there are specific times where we should be using it. To read a full line. Okay. Only returns up to the first white space. Yeah, it's fine. So I can actually use character input. This is fine. Cool. Nice. Why, in this other case, did we want to use getLine? Was there string where I was doing... Oh, and like enter a color and whatever. Enter, like choose two classes, and then we do standard get line. Oops, let's just kill this. Yeah. Like this, then we could say like that. But in this case, we only care about one sequence of text before white space. Okay, so we'll say choose a class, have that string value initialized, then we can extract it, and then we can say if RPG class is paladin or RPG class is fighter or RPG class barbarian, then we'll say okay. Yeah, it makes more sense. Okay. Otherwise, and let's see, we could do, man, I guess we could have a function for each and then use the ternary operator, but here it just makes sense to do this. Otherwise, if RPG class is wizard or ranger or I think that's it for now. Your class is a ranged backliner. Else your class is a support backliner. Cool. Oh, hold on. Where's the issue? Oh, oops. Okay, so we'll say wizard, a ranged backliner. How about fighter, the frontliner? How about barbarian, frontliner? How about a cleric? Okay. How about a warlock? That's not true because we haven't included it, which is fine. It's working as expected. What about ranger? Cool. Cool, so we can have different conditions execute depending on... Let's see. Different conditions can execute, or different... I guess different options chosen based on evaluating multiple conditions at the same time, or beforehand. Instead of checking one thing, if your guy has a sword, he's automatically a fighter. Instead, we check, does he hold a sword? Can he equip heavy armor? Can he use second wind? These kind of things. Then it's a fighter. So we can do and this, or we can do, can your, let's see, does your character cast spells? Or is it religious? Or is it well studied or well read in magic? Oh, it may be able to use magic. Or instead of ands. Okay. Magic number. If it's greater than 10 and less than 20 and not 16. It's any within a range except 16. Would return true. And if any of them are false, it'll execute, and that's because we're only using ands. Logical and. Okay. Both. It's false. Logical and is it must return false regardless. Okay. Makes sense. Yeah, if it's checking this and this and this and this. Well, if there's any and we're going left to right, and it sees false, boom, whole thing's false. Because it knows that it needs this and something else to be false. Or to be true in order to evaluate true. If any of them are false, automatically it's false. So short circuit evaluation, meaning it'll just close the circuit straight there. It won't continue evaluating and letting the current go. It'll see, oh, well, too much amperage or whatever the fuck. Boom, stop it straight away. Similarly, if the left for an OR is true, it's automatically going to return true. That's cool, because then we don't even have to do any of the other calculations. That's nice. Uh-oh, here we go. If something is 1 and the incremented y is 2, then do something. So basically, both have to be 1. But if x doesn't equal 1, the whole thing is false. So we don't even check. Oh, so we don't even check, so y doesn't even get incremented. Interesting. Okay, so short circuit evaluation. If you're using some, if one of the operators that you're using in a condition has a side effect, short circuit evaluation might not even run it. So you would expect that you run that check and then the side effect has occurred. Well, it might, or it might not. Okay. So if it's an OR, that first expression must evaluate to true. Otherwise, the second is never going to be evaluated. The first has to be true. And then for an and, the first also has to, or no, sorry. The first has to be false for an or, because otherwise it's just going to evaluate to true. But for an and, the first has to be true. Otherwise, it'll just stop, because if the first is false, it'll quit. So for or, the first must be false. For an and, the first must be true to keep evaluating. Yeah. Yeah, so don't use side effects in those, just in conditions. Sounds like maybe. In conjunction with these operators. Okay. So no logical operators with side effect using operators. Or side effect causing operators. Producing. Hmm. Hmm. Okay. Yeah. So make sure to parenthesize them, because if you want value 1 and value 2, if this needs to be true and this needs to be true, or do you want it to be this or this and this? You can, it just depends on precedence. I think it's so and has precedence. Okay. Let me see. Does it have is it the same level and it's just higher in the hierarchy, or is it actually a different precedence? Yeah, wow, it actually is. Yeah, there's 14 and 15. They're just different. So and is first. Okay. Well, they're pretty damn late. Yeah, you would think. Okay. This is value 1 or value 2 and value 3. Mm-hmm. Makes sense, yeah. If he was expecting left to right, then you'd think, okay, value 1 or value 2, that evaluated, and value 3. But instead it is value 1 or value 2 and value 3 evaluated. Good job, buddy. Yep. Yep. Parenthesize them, yo. De Morgan. Who is De Morgan? Not this and that. Oh, no, bro. Hmm. So you think not true and true is the same as not true and not true. Huh. I don't understand just yet. Not this or this. It's the same as not this and this. Oh, well, yeah, true, because if this is false or this is false, then this guy would be false. But if we're saying not this or this, then that means this has to be false and this has to be false. Because we're saying not this or this. So like if we have x and y and x is 3, and we're checking for x to be 3 and we're checking for y to be 2, excuse me, and we say not x is not 1 and x and y is not, or say x is 1, y is 2. If we're saying not x is 1 or x is 2, then we need x to not be 1 and x to not be 2, because we're saying we're checking both of these and making sure that they're both not true. Not this or this. Not this. So not this or this means not this and not this for this to be true. So not this and not this. Or here, if we say x is 1, and we're checking for y to be 2, and we're saying not this and this, then we're saying if either one of them is false, then it evaluates like this. So if we're saying not this and this requires both to be true. But for it to be false, it only requires one to be false. Or so none can be false for this to be true. But if we want this to be false, only one has to be false, which means it could be not this or not this. Okay, I think that's enough understanding, I think. So distributed, okay. So x and y are false, not x and not y would be reversing it, or flipping it, so it'd be true. So not x or not y is true, which means not x and y is true. Because we're saying x and y is false, or x and y is, hold on. Yeah, x and y is false because any of them are false, but then we're saying not, so we're flipping it to true. Okay. And then if we're saying x is true, y is false, not x is false, not y is true, which means not x or not y is true, which means not x and y. Well, x and y is already false, so true. Okay, yeah, makes sense. Cool. Yeah. Cool. The XOR. The fuck is a XOR? Whether an odd number of conditions is true? What? Ow. Oh, whether an odd is true. So if they're both true or they're both false, it's false. But if one is true, XOR. Huh. So you could use that to determine whether there's a disagreement or not. So you could say, this boolean, do students disagree? Or do parties disagree in some two-party system with two people or two groups of people? If their conclusion, their conclusion and their conclusion are their vote and their vote, if only one of them is true, or it's actually just an odd number. So if there were 3, well, yeah, but there's only, it's a binary operator though, so could just be 1. Okay. Ow. I need to stretch my leg. Well, yeah, because it needs to check both. Right? Because it needs to know. Yeah, it'd be a complicated one. So, like, he could do for 2. In one parenthesis, you could say, is this true and this not true? True and not true. Isn't that easy? It sounds kind of easy, actually. However, not equals produces when given bools. Does this not equal that? Well, yeah, it means that they're different. If it's true, or if it's false, that it means that they're different. So it's only true whenever they're different. So, yeah. Oh. 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 If A does not, or is not equal to B. I don't know if it's left or right, though. Then that not equal to C. Oh, but both of those are Jor. The total is not. Yeah, yeah, okay. Because there are 3, if any of them are different from the others. If A is not B, but it is. Let's say A is not B. Okay, so that's true. And it's not C. Okay. Okay, because the Jor still returns the proper way. Makes sense. If an odd number are true. Okay. Leave the fan on. Oh. Yeah. Oh. Not. Oh, okay. Oh, so not 3 makes it false, which converts 3 to 0, false. But then we not it again to convert it back from false to true because 3 is technically true because it's not 0. Makes sense? I don't know why the fuck I need this, but okay. Oh. That's cool. Okay. Yeah, I agree. Hmm. Gotcha. Yeah, makes sense. Okay. I knew there was gonna be a quiz here. Cool shit. Nice. Nice. I get to write some shit maybe. Oh, actually, nice. Okay. True and true. Or, so this guy's not even run because or evaluates the true if either are true. So true and true is true. And then we bracket this boy. Boom. False. We know that this guy is automatically here. Oh, hold on. So none of them are bracketed because we still need to check for true. So this is false or true, true. Yep. False and true. Dude, true is such a weird word now. I don't like reading true. True? Is that true? True is so weird. I don't like true now. I really don't like that word. It's just, it feels like it's not real. True. False. And so we see that, well, oh wait, fuck. I forgot that we can do it inside the operators. I haven't been doing this properly. Okay. So know that this is true. So we still have to check this guy, so he's not bracketed. So true and true, cool. Or, well, or evaluates to true if any are true. So we bracket this guy, we don't evaluate him. False and true. Well, we know that this evaluates to false instantly because the first is false. So we bracket this guy. But then this guy could be true, so we don't bracket this guy. So we bracket this true. Cool. So this is false or true, so it's true. Yep. False and true. So we know that this guy is false, bracketed. False, bracketed. Or false or true. So we know that this guy is something or something or something. We know that one of them's true, so it evaluates to true. And then this guy's bracketed, and that's the only one that's bracketed. Because we still need to check to see if any others are true. So we know that this is false, or hold on. Okay. So we know that this is false or true. So this is true. And this is true, which means we still need to check the rest. This is true, no brackets. Cool. Not 7 is greater than 6, which is true. Or, oh, well, we know that this is true, so we don't need to evaluate the rest. This is bracketed, so this is true, so this is, it evaluates to false. Cool. Not 7 is greater than 6, which is true. Or, oh, well, we know that this is true, so we don't need to evaluate the rest. This is bracketed, so this is true, so this is, it evaluates to false. 7 is greater than 6, which is true, so we don't need to evaluate the rest. This is bracketed, so this is true, so this is, it evaluates to false. Cool. Is it just 2? Oh, okay. We wrote a function to determine whether a number is even that looked like this. Hold it. Oh yeah, because we're using remainder. Okay. Oh. Using it instead of equivalency. So we could just say so we're returning a boolean here. How do we take a number remainder 2 is 0? Well, could we just do this guy and then mod twice? Or sorry, and then not twice? Excuse me. So we could say x remainder 2, and that'll tell us, okay, well, if it's anything but 0, hold on. Shit, maybe we not it 3 times. Hold on. Because if we say, let's say 3 mod 2, okay, so that's 1. 1 is not 2, so we need to return false. Well, we had 1, so we need to say, we had 1, and we need to convert, in anything but 0 is false. So 0 is true. 0 is the only true answer. So we take 1 and convert him to a boolean by saying not, but now he's 0. False is actually the correct answer in this case, but not for the reason we want. So we have to, we say not to convert him to a or maybe 1 not is right? So if we said 68, well, let's just do an actual number, like 7 and 2. So 7 remainder 2 is 1. 1 is not 0. Oh. Oh, wait. Using the not operator instead of the equivalency operator. So not using the not equal to operator, using the not operator. I mean, we could say just return not equal to. We'll tell you that this is odd. And then we could say not that whole thing, not equal to. But in this case, we're using the not operator. So it sounds like we're comparing 2 integers here. Right? And we need to take an integer and convert it into a bool by not using the equivalency operator. So this guy evaluates to 1. That's not 0, so we want it to be false. So we say not that. If we say 4, and that's 0, then we say not, I think we just say not this. Let's see. So if we did 14, all right, we say enter an integer, value initialize them so we can give them a value and remove the garbage value, extract the value, and we put 14, okay? So 14 is now in x. Okay, and then we say if is even x. Okay, so we pass x by we just pass him by value, so we copy his value into this other integer here, which is still efficient because it's not a standard string or a C-style string. So we say, okay, 14, all right? 14, remainder 2, well, that's 14 divided by 2, which is 7, no remainder, so this is 0. 0 is 0, true. But instead, we could say 0, okay, that's true. But if we return 0, it's returning false, so we say not. Return not x remainder 2. Okay, that returns true. What if we said 15? 15 divided by 2 is 7 and whatever it is, right? Isn't it just is it just 7.5? Yeah, I guess so, right? Yeah. That was stupid. I'm in a weird position, so I can't think. That's my excuse. So regardless, the remainder is 1. So 15 remainder 2 would be 1. 1 is not 0. So this would remain false. Or this would return false. Cool. If we do 15 remainder 2, this is 1. Which means returning 1 would be true, so we need to say not. I think we could just put not right here. What if we did 69? 69 remainder 2. We end up getting 1 as the remainder. And then we just say not. But if we had 68 divided by 2, well, 68 remainder 2 is 0. That's going to return false, so we say not. I think we just put not right here, seriously. And then we say if is even, well, it's returned true or false. And then we say it's even or not. I mean, I think we can just do that. Oh, okay. I'm going to do that real quick, and then I'm going to stretch more when I'm reading other stuff. I hate that. Of course, we get to the quiz right when I'm stretching it out. Oh, legs feel a little better, though. I need to keep doing that. Be more mobile. Don't just sit the entire time. Okay. Oh, and more quiz after. Nice. Oof. Okay. How do I... There we go. Oh, there we go. I think the arms weren't in. Okay, so we could do... Write a function to determine... I'll just start from scratch. So we need output so that we can extract output. Write a function so we get an integer and then we return whether it's even or not. So we could just say enter an int and then int user int value initialize him, use standard character input to extract him. And we say if is even user int. We do something. Well, we need user int. User int. So this value is known, but it's not const. But we could pass the value to a const, which means that we could, I think we could do a const expression bool is even, and then give it, and then we just convert this to a constant. Whatever. User number. And we return something. Let's just say return true real quick. Okay, cool. I think that's the only issue it's having right now, which is okay. All right, so is even, and then we will just say, or so we'll say if is even, then output user int is even. If not, or so otherwise, if it's not even, output user int is not even, or is odd. Okay. And we will return not user number remainder 2. So if we say 68, it is even. If we say 67, it is odd. If we say 4, it's even. If we say 5, it is odd. If we say -2, it's even. If we say -1, it's odd. And the reason that works is because -2. Hold on. So we're saying not 0. Because if it's not 0, so 0 is the only way that it could be. Well, hold on. Oh, hold on. So if we say -4 mod 2, remainder, stop, Jesus. So if we say -4 divided by 2, we know that's -2. The point is that there's no remainder. So it doesn't matter what the Like there's the big number, first number, there's the number you're dividing it into, and then there's the number that says how many times it's gone into. We don't care about any of these. We only care about what is left, the fourth number. So we have 7, we have 5. 5 goes into 7 one time with a 2 remainder. So there's the number, there's like the divider, the divisor, and then there's however many it goes in, and then the remainder. All we care about is the remainder. So the point is -2 goes in, or 2 goes into -4 -2 times. Nobody gives a fuck about -4 or 2 or -2. We only care about how many's left. 0. So this is indeed 0, which means this would be returning false, but we want it to return true. So we say not to make it true. If it is instead 69 divided by 2, we know that 69 or remainder 2 is 1, which means that if we return 1, or because how many is left over? 1 is left over. Doesn't matter how many times it goes in. -69. Oh, okay. So now it's negative whatever 34.5 or -34, and then 1 remaining. We don't care about -34 or 2 or 69 or -69. We only care about how many's left. We care. So we see 1's left. Well, 1's left. This would be return 1, but we need to flip it to return false. Cool. I mean, I think that's the strat. -377, -378. I think that works. I think that's fine. Is there a better way of doing this? This is a const expression bool, and the reason it's allowed to be const expression is because its parameters are known at compile time. It's a constant. Constants are const integral values, which means that they can be known at compile time, and they're allowed to be used for const expressions. Compared to a const standard string before C++20 or 17, I don't remember, one of those allowed it. I think 20. Okay. And at compile time, this is being passed 0. So we have 0, passing in is even 0. 0 is here. It's const. Cool. We can just do that, right? Yeah. Return not x remainder 2. Yeah. But in this case, you're doing x. But I don't like saying just x. Not that. Cool. Quiz. Oh wow, quiz is fast. Wait, what the heck? Oh. Yeah. So remove any ambiguous. Remove any ambiguity by using parentheses. Okay. Yep. 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 Yeah, just in case of short circuiting, because then, especially in a condition. Yep. Oh yeah, if we're talking about side effects, we're calling a function and then adding something in it. It makes sense to just do the incrementation or whatever the side effect is, and then do it. Like don't pass x assigned 4 into the function, because then sure it maybe passes x is assigned 4 into the function, but like when that stuff is really evaluated, I don't know. It makes more sense to do these separately. Okay. Oh yeah, especially the same one. Yeah, like y or a plus plus y, but then y is greater than 4. So is it y is greater than 4, or is it plus plus y first? And then whatever the operator is between them. Which one happens first? Okay. ternary operator, arithmetic operator. Okay. Yep. Oops. I just press space. Yeah. Oh, it just goes down like some amount. See evaluate or the operator evaluates to. Oh, okay, yeah. If it's true, then this expression returns x or y otherwise. Yeah. Okay. Let's do. Is this any good? Bro, it's just straight music, man. Who wants this shit? It's just an orchestra, man. What about this, huh? Dude, a modern piano back then? That makes no sense at all. What about... And Campfire's kind of good. Excuse me. Okay. Parenthesize the whole thing. So parenthesize the condition if there's an operator within the condition here, see? Excuse me. And parenthesize the whole thing if there are other operators. Entire if it's used in a compound expression, so used in an expression with other operators. So this or this whole thing. We'll parenthesize this whole thing because maybe the or happens and it's this or C. No. We want it to be or the whole thing. And then parenthesize the condition if it contains other operators. Yeah, makes sense. Yeah, because if it's just, 3. Okay, well, 3 is true. True or whatever. Well, true would automatically be this. But how about is dead? And we pass is dead into this from some character. And then, is dead? Okay, then print is now dead. Oh, not dead? Print is not dead. Is back to life. I don't know, something. Relation operators can be used to compare floating point numbers. But be careful. Yeah, they can be used, but be careful. Oh, okay. Relational compared to equality and inequality. Yeah. Because like 0.0004 and 0.0005 or 0.0041 is more likely to return the correct answer when using greater than or less than, or I think. But when we're using equals or not equals, not necessarily. Because like 0.1 plus 0.1 might not return, or equal, or is 0.2 might not return true. Is equivalent to 0.2 might not return true because of the rounding errors from 0.1 plus 0.1. Logical operators allow us to form compound conditional statements. Yeah. So like, is dead, or is being revived, or is dying. All of these, whatever. There should be some sort of sound playing or something like that. Complete the following program. Okay. It's a constant expression. Mary apples. So she has some amount of apples, 3 apples. And we output Mary has get quantity phrase Mary apples. Get apples pluralized apples. What? How many apples do you have? Okay. It has this many apples. Okay. Oh, okay. Oh, okay. Mary has some number, or so she has quantity phrase. So is it a little, one, none, a few, and then apples. Is it apple, one apple, or apples? Okay. So this is either apple or apples, And this is none, one, a few, a single, or wait, what? How many? A single, a couple of, a few, many. How many apples do you have? We put in a number, and then you have one, this, that, whatever the fuck. Okay. So we're using string, other stuff. Okay. And it should use the conditional operator. Seems like this is just one conditional. So we pass in the phrase, and the phrase, okay, there's 3. Okay, so it checks. Is it 0 or is it less than 0? No. Is it negative apples? What the fuck? Okay, whatever. I guess error check. It's fine. No, no, no. Oh, 3. A few. You have a few, and then the condition, and then pass in the number. Is the number more than 0? Is num apples greater than 0? If it is, return the string apples. Otherwise, not. Oh, man. Of course he had to make it easy. 1 is apple, otherwise apples. But what about 0? Oh, well, I guess you could say negative apples, no apples. Yeah, I guess you wouldn't say no apple. So, I mean, there's only 2 options. You either have apple or no apples. That's interesting. I have 1 apple. I think an apple is only 1. I have no apples. So, a billion apples and no apples? Same shit. English is interesting. Okay. Alright, sounds good. Alright, I'll just write the whole thing. So we'll say we need input output. We need, hold on. Do we want string as well? Alright, what is it returning? Is it return the descriptor? Oh, I guess it could just return literally a C-style string instead of actually having to use string. Yeah, I guess so, because we're just checking the numbers. We're not checking strings. Okay, maybe. Oops. Okay. So we'll say Mary Apples, const expression int, Mary Apples. She has 3 apples. And then we output Mary has. Oh, okay. So we'll say get quantity what do we call it? Get quantity word. I'm just gonna call it get quantity word. Mary apples. She has space a few, or she has, yeah, a few space get apple pluralized plural check, what is it? Apple plural word, plural apple, plural, what do we call this? Get apples pluralized. Mary apples. Mary has space a few space either apple or apples. Boom. Okay. And then how many apples do you have? Or let's just build this. Those will be 2 undefined. Okay, cool. And then there's no colon, no semicolon here. Yeah, it's fine. Those are just twice because those appear twice. What's the last one? Yeah, just it's 2 errors for a semicolon. Okay. So there are these types of errors and then these types of errors. So there's And they just double. They always double up. Okay. How many apples do you have? Okay. And then we have int user apples. And then user apples. We get however many apples. And then we say we output I have get quantity word user apples. I have a few space get apples pluralized user apples. Okay. So we're going to return, what are we returning here? We need to return the string. So we need to, don't we need string? I mean, I would say string. Returns the following descriptor. What are we returning? We're returning not characters, we're returning strings. Bro, I'm using standard string, dude. That's what I'm putting in here. We don't need a string view though, because we're not viewing anything. So this is easy enough. We'll say standard string, it returns a string, get quantity word, and then we'll say int constant, because we can implicitly convert constant num apples. Okay. And then we can say, hasn't returned anything yet. So we'll say if, or return, let me see, hold on. Do we want to do if this, return else if this, return this? I think so. Alright, this might be a bad way of doing it, but if num apples, or no, hold on. Is num apples less than 0? Okay. Return. Yeah. Yeah, because we have to return something, so we do need this. Alright, return negative apples. Else if num apples is 0. Return no apples. Else if num apples is 1. I mean, I think I have to do this. Return 1 apple, an apple, an apple. Else if num apples is 2. Return what, a couple, a few. Alright. Return a single negative no, a single, a couple of, return a couple of, else if num apples is 3, return a few, and then return many. Else, well, I mean, these cases all cover, these cover 0, 1, 2, 3, and these are ints. Else if num apples is greater than 3, return many. Yo, why did you just... Why are we here? And else, return negative. Okay. So now that one's cool. Expected a statement. What? Oh, oops. Oh, yeah, that was probably why. Yeah. Yeah, because this covers 0 to infinity. Or at least, if it's a const regular 16 int, then we're talking 2 billion, 2 point something billion, 2.2 billion. Did I fuck my glasses up? Ah, fuck. That's fine for now. Yeah. Else negative, we don't need to say negative and then else something else. We'll just say else negative. Because if it's not 0 or higher, then it has to be negative. Okay, cool. And then we'll have another here. And in this case, we're returning another standard string. And it is get apples pluralized. And it is, again, a const int num apples. I mean, we could say... Would this be fine? Const expression. I mean, apparently we can do that. I mean, it doesn't have an issue with that yet. So, I mean, maybe I was just using it wrong before, const string. And then, I mean, we'll try here. Apples. And then it's just a ternary operator, return. Nothing else yet. So we'll just return num apples. No, it has an operator in it. So we need num apples. Is num apples 1? Yeah, so I need some sort of operator. Yeah. Is it 1? If it is, return apple. Otherwise, return apples. Look at me, man. Okay, let's just see what it looks like here. Mary has a few apples. How many apples do you have? I have 7. All right, so let's just say you have. I have a lot. You have many apples. How about I have 4 apples? Still many. How about 3? I have a few. How about 2? I have a couple. How about 1? I have a single apple. How about 0? I have no apples. What about if I have -3? I have negative apples. That works. So Mary has 3. It's known at compile time. She has this quantity word, and it's determined here. Space, and then however many apples. It's either num apples, or it's either apple if 1, or apples if not. Because if I have 0 apples, I have -1 apples. If I have 2 apples, 3 apples, 1 apple. 1 is the only answer. Even -1, I have -1 apples. I guess so, huh? Alright. But in this case, we're just grouping it into negative because you can't have negative apples. So, and then for me, we're prompting the user, say here. So this needs to be known first, but then we're just prompting the user. And then we're initializing this. This can't be const because we're then assigning to it. So this has to be just non-const. And then we're extracting value to it. Then we're saying you have, well, how many? Convert the number to a word, and then, or obtain a word from the number using the number, and then space, and then you have apple or apples. Well, it's ternary. Do you have 1? It's apple. Do you have not 1? It's apples. Excuse me. Excuse me again. So the only question here is if I can shorten this guy up. Because I don't think I can off the bat, because we have separate condition cases, which means I can't split them. So we want no apples to return only if we have 0 apples, not if I have less than 1 or anything else. So I think it needs its own condition. But same with 1, 2, 3, and greater than 3, because these are all separate. But at least 1, 2, and 3 for sure. We only want 3 if we have a few. So we can say there's less than 0, 0, 1, 2, 3, greater than 0. So there's 0, there's less than 0, and there's 1, 2, 3, or greater than 3. 0, 1, 2, 3, greater than 3. Yeah. But then there's greater than 3 or less than 3. What if we say else if num apples is less than 0, then, yeah, because not all paths, because, what are the paths? So I mean 0, 1, 2, 3, and I guess it always wants an else, really. So what are the paths? 0, 1, 2, 3. Yeah, I guess because we could technically say, if we said else here, And then we did 1.1. No, because it just converts it, I'm pretty sure. Right? Yeah. So if we say 3.1, it's a few. But if we say 3.9, it's still a few. If we say 3.99, it's a few. But if we say 4, it's many. And it's because it just drops the end. So, I mean, all the things would return a response. But in terms of at compilation time, we need to capture all these values that are between these. I guess, even though they're ints. So we say else. So we need individual answers for these. But then we can use one more condition to capture anything greater, and one more to capture anything else, and then one other thing to capture. I mean, we could say else if less than 3 negative, and then I mean, I think that's it. I think that's the strat. I'll take it. I'm happy. Fuck. But that's weird though. I want to just return. I want to know where it's at. I want to. Output a value here. So or here, sorry. So this is. We're returning a value here. And then we're killing it afterwards. C-style strings are cool because they exist through the lifetime of the program. So if we did standard string view, we wouldn't, but we're not, I guess we are copying it from here to a temporary variable. So maybe it actually is slightly more performant to just say string view because these are C-style strings. So 3, yeah, 4, a bajillion. What if we do too many? Is it gonna say nah? It'll still, cause it'll yeah. Odds are. -1, negative big number. 1, 2, 3, 2, 2, 3. Oh, sorry. Oops, 3. Okay. I don't know what I pressed. How did I do control my? There must be another hotkey for debugging. Oh, it's getting cold. Oh, like you're tired. We're at like an hour and a half, 4.5 more hours to go. I said that I absolutely must do the coding for 6 hours straight here. So I need to just do it in the morning, lock the fuck in, and then I'll have my big afternoon as like a massive reward. Because if I start and I was doing D&D till 6, or watching D&D, or watching something else for inspiration or fun or entertainment till 6, or till 3, sorry, sure, I have like 8 more hours in the day. But like last night, I got tired at 10. I just went to bed. I did 2 hours of coding earlier, and then I had planned to do 2 more hours later in the day. Really, I was gonna do like 4 more hours in the day to get 6, and then I just didn't. I need to just fucking man up and do this shit as soon as I can once I get off of something. It's just that I'm weak, so right now it's tough. The enticing pull of waking up and chilling for a sec is more enticing than waking up and doing something. Just like it's more enticing to go home from work and watch something for a while, a couple hours, and then lock in instead of locking in straight after work, because it goes from burden to burden. Waking up is a burden to, or like, it's not intuitively like a super fun thing because I have to shower and do whatever. I just want to chill after. But instead, if I do that, then I have all this time to fucking entertain. So that's what I need to do. Okay. So we can use a string view here because we're returning C-style strings, which are alive for the lifetime of the program. But if these were, let's just say we created a variable. If these said return whatever, I could have one more line between each of these, and we could just say apple word or quantity word, assign it no, assign it this, or assign it this, assign it this. and then after these would just be returning that word copied to each one of these. Then we would be returning a standard string, and if we use string view, so we return a view to it, but then we kill it here once the function terminates, then we wouldn't be able to view it anymore. So we'd be viewing whatever the memory looks like after the values have been killed off, I guess. Something like that. Yeah, I don't have any issues with this. I think this is fine. Yeah, we're just saying if this, do that. If this, do that. Oh, we're saying ifs instead of else if. Do we even care? What's the difference between if I say, oh, otherwise return many? I wonder so what's the difference between saying if and then, because it sounds like this is, oh, I heard some shit above me. I didn't care until too late. All right. If this is true, it'll do this. If this is true, it'll do this. If this is true, it'll do this. Or, if this is true, do this. Or if this is true, do we need the or part? I mean, these can still be const expressions because their values are known at compile time. Because they're only getting ints. So, and a constant can be, well, it's not even, yeah, because this is a constant. So we're taking an int and we are creating a constant out of it at compile time, and a constant can be used in a const expression. So this guy can be a const expression. Okay. If. Let me go see what the conditional chapter was look like again. Let me sit properly. Oh. Actually, I'm just reading right now. I'm not working. So I'm going to do a stretch action while checking the conditional spot to see, because I think I've only ever seen if else instead of if return. I mean, maybe it's well, yeah, I mean, it feels like it's the same shit. Do so every time. So go to perplexity real quick. If this, do this. If this, do this. If this, do this. Or if this, well, yeah, it looks the same. Each is evaluated independently, and all conditions are checked. This checked, then this checked, then this checked, then this checked. But if there's a return here though, then it won't check this. And then here, if there's a return here, then these won't be checked. So the point here is if this, it'll do this, but then it'll keep doing this. It'll keep checking. Versus if this, else if. If it's doing this, if it does this, then it won't do the rest. If it's this, then it won't do the rest. But if there's a return in here, then it won't do the rest anyway. So maybe the point is you can trim it up. If you have a return in each, you can just do ifs instead of having to do else if for each time. Oops. Yeah. about if each condition has, or each code block has a return statement. That way, an if would behave the same as an if, else if, because each code block, yeah, because if any code, or if any condition is true, no subsequent conditions will run. Fuck, I should have got different chips, man. More readable. Mutually exclusive. Yeah, I guess so. Alright, well, fuck it, man. I mean, I'll just stick with what I did then. Bit manipulation. Holy. We getting to that low level, yo. Oh, chapter O. Does it even have a quiz? Optional shit? Holy. Oh, it is optional. That's why it's O. Okay, let's learn. Bits, bruh. Let's get them bits going. Oh, shit. Treat each bit as an object. Whoa. It's a byte. Okay. Yeah. Bulls, it's wasteful. Yeah, because we only need one, bro. We don't need more than a bit. Yep. Yeah, I'm gonna read this because there might be a case, there might be some sort of general optimization framework. Just reading about optimization is probably good. Like if we had government employees all read things about Occam's razor, cool, dude. If you can say something like this, but you can actually do a little bit more effort to say it like this, and then people can more easily read the fucking document, bro, do that. But nobody does that. I think I speak out of ignorance, but that's what I'm assuming. So. Oh. Hey. Oh, so if we can still only use bytes, then instead of us just doing one bit, one variable in a bit, another variable is a bit, we're actually just doing 8 separate ones, maybe? Modifying individual bits within an object, within one object. Okay. So we're basically just putting, it's like in a fishing box. A fishing box is like a bucket. So I could put one lure in there and then go fishing. But what if the lure is really small, but the bucket's pretty damn big? There's room for 8 lures. Well, I could put in one of those little, like, hex thing, or not, like, crosshatch things. And then, oh, look at that. I can put the lure in one, and then I can see how much room I've got. I've got room for 7 more. Well, why not use that, motherfucker? Well, now we can, allegedly. Graphics. Ooh, optimization. All right, this is going to be good. Okay. Oh. Oh. Yeah. Oh. 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 Oh, I forgot that 16 is the 32,000 version of an int, not the 2.2 billion. That's the 32. Whoops. And then the 64 is the centillion, or 5 pentillion, 4 pentillion? No, 8 pentillion. Yeah. It's unsigned to 16 pentillion. Oh. Let me make sure 64-bit int 8 pentillion. Oh, fuck. Fuck. It's quintillion. Wait, quintillion. Oh my. Hold on. Wiki, large numbers. Here we go. Why is it quadrillion quintillion? Why isn't it quad pen sex sept or hept? Damn it. It's quintillion. Bro, who is Quinn? Fucking stupid ass name. What is a pentillion? Pentillion doesn't exist. It means quintillion. Oh my. Because penta is... Man, I'm saying pentillion. Fuck off. Quintillion is gay as hell. I don't need that. Oh. The bits are called bit flags. Okay. Oh. Oh. Flipped. Bit flip. Oh my goodness. Oh. Oh. Hmm. Okay. Hmm. Oh. Okay. Makes sense. Feels like we're saying not set for 1 byte booleans because we haven't used the other 7 bits. See what the temp is outside. It seems like it's fucking cold. Okay, that's insane. It's actually 64 out right now. Oh my god, it's getting to the 40s. Holy, tomorrow's gonna be cool in the morning. Fucking Texas, man. I need to eat something. It's not time for chicken yet. I'll probably do chicken at like 12. Once I'm at like almost 3 hours, then I'll do that. I'm gonna cut an apple really fast. It's 15, let's see how fast it takes me. How fast I can... Okay. It took too long because it took longer, I guess. Oh damn! Oh, 2 minutes, not bad. But it took that long only because I had to go outside and take my trash outside the room. Okay. Unsigned to avoid wraparound, unless we really want it. Or well, there would be wraparound. Never mind. That was stupid. Unsigned just for the sizing because we're probably not using negative. So we get bitset size 8 or 16 or whatever, and then call it my bitset. Oh, so meaning. Okay. Standard bitset, and then how many? There you go. Size T? Yeah. Cool. Size T bits. It's that. It's called my bitset. We have. Oh. And it's a long. Oh, it's big. Wait, really? A long? Oh, wait. What am I doing, bro? Let's do that. Cool. Alright, it exists. Standard bit set and then unsigned int. Or we just say how many bits we need. So we're just defining the size of the type. And size T is an unsigned int. Okay. Lightning? It's just a car. Oh, okay. So we're saying given a sequence, bit 0, 1, 7. 0, 2, 6, 7. Okay. I'm manipulating the bits. I'm about to break my computer. It's over. Oh, so bitsets a class. Okay. So I can query a specific bit to see what it is, and I can output that probably. Oops, well, too much peanut butter, but. Okay. Bitset 8 bits. Okay, so we're finding some 1 byte's worth of bits. So it seems like memory can only be split into bytes at the object level, but each object still has multiple bits in it. So we can't make an object and only use 2 bits. We can use a byte and then do different things with the bits though. Check something real quick. Excuse me. Okay. All right, I need to put the dishes away real quick. Okay. So we can query it. We can set it. It does nothing if it's already on. So if it's 0, we can set it to be 1. If it's on, we can reset it. Or we can flip it if we don't know what it is. So we could say we have bit set. Let's do this again. Include bit set. Oops. And then we'll do bit set. We'll do an 8, size 8. Call it my bit set. Yo yo. And we'll call him yo yo. We'll just value initialize them. And then we'll do my bit set yo yo dot test. Yeah. Position 5. Position doesn't have 8. 7. Oh, and then we need to output that. Standard character output. Bro. Oh, we didn't include IOStream. That'll do it. I don't know what's first. Whatever. Include IOStream. That. About position 1. Or position 0, I guess. Okay, so it has nothing. But what if we do... Do I need to say 0B? I guess so, huh? Or is it 0B? OB. Yeah, it is 0B. 0B. Oh. And then oh. Or 1111. And then we'll just do... We haven't done 4 loops yet. So we'll just do 1, 2, 3. And then, same thing. 4. 4. Cool. Alright, so I can test them. We could do... So we could then do my bit set yo dot flip 0, and then output my bit set dot test 0 again. So it should be 0 and then 1. Oh wait, sorry, that's why, because it wasn't value initialized. I forgot that I gave it that. So 0 and then 1. Oh yeah, so we have set, so we could do dot set 0, but then we could do, or oops, sorry, I don't want to assign it and do this, so we'll just do test 0. But then we could do set 0, but then we could do my bit set. We could unset, or sorry, reset 0, but then we could do, and then do this again. And then we could do my bit set flip 0, and then do that again. So we're printing it, and then we're setting it, and then we're printing it, and then we're resetting it, and then we're printing it, and then we're flipping it, and then we're printing it, and then querying it. What is query again? What is query? Oh wait, query isn't even it. There's set, there's flip, and there's reset, and there's test. So test gets the value, set makes it, but doesn't output it, but changes it from 0 to 1, or from 1 to 0, or flips it if you don't care what it was. So we can do this. Excuse me. So it's 0, but then we set it and then print it, and then we unset it and then print it, and then we flip it and then we print it. Okay, cool. We can do a bunch of shit. Okie dokie. And then the point is I could use this as one, so I could create one as a bit set, and then use those values as Boolean values. So we could, I'm not going to save them, but I could go and, I mean, if I store the positions, it'd be kind of annoying because it seems like these are magical numbers, and it wouldn't be efficient to make a string. Or hold on. Yeah, it wouldn't be efficient to create an integer to remember the position of this, because then an integer is whatever, 2 or 4 bytes or something like that. Just to remember a 1 bit thing, we're literally being 32 times inefficient just to make it not a magical number. So, because here we're doing magic numbers. I mean, not necessarily magical, but they're not known straight off the rip. Mm. Uh-oh. See, that was bad. Okay. Next we have this. We're setting 3. We're flipping 4. And then we're resetting 4. Okay. Mm-hmm. Wait, what member functions did we even do? I don't remember. It was like, I don't remember. Oh. Hmm. Oh wait, we can? See, it seems like this just ain't it. I mean, what? Oh. So we have 1 bit set, and then we update those separate variables. So we have a bunch of objects. and their values are stored in the bit set. And we're saying maybe unused. So that we don't have to use them the entire time. Okay. Hmm. Hmm. So if you output a bit set, the bit set is just what is it just an unsigned? So it's actually okay with those digits. It seems like. Oops. If we print him, it's that. What happens if I do that? Oh. Oh. Oh, here we go. It's cool. Overflow. Bump bump. Okay. Okay. So because it's a standard bit set, it is automatically it is an 8-digit binary code, binary sequence. So if I assign it an int, then what? Then it automatically converts it into binary. What is it? SteamDB. Yeah, forgot. Wow. And the francs are up big. Ruble. Those are both broke. Okay. Hmm. Enumerations. Okay. Get or set multiple. Okay. It's a size T. Oh, interesting. The number of bytes needed to hold the bits. Yeah. What the heck? Okay. Hmm. The typical number, meaning that it's still giving more. The number of bytes needed to hold the bits rounded up. Yeah, but it should just be 1 byte. Yeah. Yeah, it's crazy. Okay. Oh no. Oh yeah, because I could do 16 and have it be, yeah, it makes sense. Count is the number that are true. All, any, none. Okay. So how many bits there are, how many are set to true, are all true, any true, or some true. All, any, or all, any, or none. Yeah. Bitwise operators. Uh-oh, here we go. Left shift, meaning what, like swap? The bits from X are shifted by left by M positions. New bits are 0. So what happens to the rest? Does it add a new bit? I don't know. Or do you lose the last one and it pops them off? Oh, so these are all bitwise guys. All right. They do not modify. Oh, yeah. Yeah. Okay. Makes sense. Oh, instead of it printing, what, hexa or something? Hmm. Okay. Use unsigned stuff. Oh. You lose him. I knew it. You shift 4, GG. This should say right side. Okay. Okay. So if we do okay, we say we need a bit set. We'll just say cool. So wait, what? What? Oh, okay. What if we did that? Start. Oh, okay. I guess we do need the. I'll do that just for readability, and then OB. Can I do space? Fuck. Oops. Okay. So we'll do that, and then we'll do dot or shift left by 3. So we should lose. It should be 1 and then all zeros, I think. What? With no discard attribute. Oh, so it's just a warning. So it has warnings for shifting. Well, if I shift at all, then I lose it though. Well, unless it's not set. So let's find out. So if we said... Oh, still. Oh, and I can give it less then. So I can give it 4, and then we could just do that. Oh, cool. So I can give it I can do a bit. Oh, it's not actually an object that's less than a bit. Because it's a bit set in bitsets are in bytes. And rounded up for convenience / performance, not for memory. Okay. Oh. Wait. So what, we just aren't allowed to shift at all? We had 0. Oh, what if I'm not allowed to actually... It doesn't modify, it just... Aren't allowed to do that. We can only output, I guess, what the shift would be, which is weird. We're moving them to the right. We got bop, bop, bop. So he goes, lose 1, that was a 0. Lose another 2 zeros, lose another 3 zeros. Okay. Indian? Well, yeah, I mean, I guess the most significant is the leftmost one, because if the value is 128, or 255, oh, well, yeah, 120, is it 127? So 128's 8, but if we had 4, or sorry, 255 is that, but then 127? Yeah, so if we had 127, and then we popped the top guy off, and we shifted him, we'd lose a whole bunch. Or if we shifted to the right, right shift towards the least significant and the most significant. So if we shift towards the most significant, then, I mean, if we shifted from the right, we would lose the most significant guy. It would go from 1 to 0, which means we would lose 64. So we'd go from 127 to fucking whatever, like 63. What? Yes, they are. But it probably just depends. Hmm. So we have an unsigned int. Oh, and then we are assigning him. So what if we did that here? Oh, I can do that. But I have to actually assign the values. Oh, yeah, I can. I can't just do the shift and then what was the issue there? Oh, we're discarding the return value. Okay, so I guess this is a function is what it's saying. And it should be returning a bit set of size T4. But it is not. We are discarding it. Basically calling a return, we're calling a function without doing anything with the value. So it's a warning treated as an error. Okay. But if we assign him, and we do 4, and we lose them all. Okay. But we could also do unsigned int, and we'll just assign it has issues when there aren't binary values in it. Makes sense. But then we could cast it. We'll just call him bit set. My bit set. And we'll say, oops. Oh, because bit set was, okay. Static cast to a standard bit set of size 4. Uh-oh. Oh yeah, we weren't even casting it. We were just outputting. So what is this even doing? I get, this is just a temporary variable. So we have an unsigned int, and then we have this guy, and we know he's binary because of that. If we took these out, then oh, he's actually still happy. If we just said 2, oh, he's still happy. All right, weird. And then we output a temporary bit set. What would happen if we did this? If we did that versus my bit set, we're not printing him as a bit set, printing him as an unsigned int. Okay. So in one case, it knows that it's. So when it sees standard character output, it knows that it's doing output. Versus when it sees just an unsigned int, it looks at the type of the operand. Standard count is a character output. So yeah, we can't shift a character output some number of bit set. So yep, makes sense. Same thing for extraction. So yeah, we could do, couldn't we? Bit set include IO stream. And we could say, excuse me. Alright, so what if I did 2, 2, 2, 2? If I did 5. If I did 4. 3. Okay. But that's cool. Oh. So it's cool at taking the binary, but it doesn't want to take anything else. Okay. Because it's a bit set. Okay. Operators changing their behaviors based on the type of arguments. It's called operator overloading. Okay. So by default, there already is some operator overloading, where the extraction and insertion operators are also the bitwise shift left, shift right operators. So we're outputting, so we're using the insertion operator, but then we're also doing the left shift. So we have to parenthesize it so that we know. Because we are operating on a bit set and an integer, so we're shifting the bit set by the integer, not simply outputting x and then 1 and then the rest. Need like a footrest or something, maybe. Just put the feet behind, I guess. Yeah, I guess so. Makes sense. First line prints the value of x and then 1. Yep. Versus printing the shift. Makes sense. Shift to the left. Yep. De simpere frips de Brit. Okay. Not for the entire bit. Okay. Well, yeah. Yeah, of course it does. Yeah, because in this case, it's whatever. 4 plus 8 plus 16 plus 64. Or, sorry. Yeah, 4, 8, 16, 32. It's like 50 something. But then we flip him. So we have this guy. Or yeah, no. Actually, I was taking these as two of the same. I wasn't even reading, really. It was stupid. 3 now turns into what? Like 11? Hold on. 12, sorry. Whoops. 3 turns into 12. Yeah, so if we have one bit set and then another bit set. Oh, and we just give them both the same thing. We're giving it 4, and then we're giving the other one 4. But the size 8 one can be bigger. So the first one can only go up to whatever 15. The second one can go up to 128 or 127. So we output initial values, bits. Okay, done that. And then we're taking the values 4 and 4, but then we're flipping. So from 4 to 11, and then to like 123 or something like that. Or oh, sorry, because it's 257. So yeah. So initial values are 4 and 4. After they have flipped, the values are now 11 in that. Yeah, it makes sense. Yeah, I mean, flipping the values. Yeah, yeah. Makes total sense. Yep, leading zeros don't change the value. Two unsigned long member function. So I could say there we go. So we have a standard bit set, size 4, and it is called my bit set. Value initialized to be 1011. And then we could output my bit set. And then we could say output the bit set. Then 2 and unsigned long. This is a function. So we're passing it a number and it returns an int. So this whole guy is whatever the value is. Returns, well, yeah, an unsigned int, which is just a long for extra memory. Okay. And then I wonder if we could do 2-bit. Could I? Print static cast to standard unsigned long, or oh, we don't have C standard int? Yeah. What? Oh, unsigned int, not unsigned long. So there's unsigned int. Whatever, we just do UN 16T. That's the type. We're passing it my bit set. Uh-oh, cannot convert. Okay. So we used too long. Yep. Not. So we could do we get bitset, input output, and then we'll do bitset of size 4, call my bitset, and then we'll value initialize them to be, or we'll just list initialize them to be that 11, and then what am I hearing? How do I even? There it is. Wait, is that the right one? How do I get these values? I don't even know how to. Oh, shift. Oh, so function to get. Okay, I get it. My bitset. Oh, so that's how we flip them. Okay, try it again. Now I know how to do it. So we'll do bitset. We need input output. Oops. We need a bitset. We'll do size 4. We'll do size 8. And then call him Jimmy. Jimmy the bitset. And then we'll give him 1111 0101, which is like 200-ish, something like. He's only lost. Yeah, he's like probably 240, I'd say. Specifically, it's minus 2 and minus 8, so it's minus 10, so it's 245. Yeah, it should say. Yeah. So we'll output Jimmy the bitset, and then so we'll say bit sequence, and then that guy, and then int value Jimmy the bitset dot to long. Okay. And then we could do Jimmy the bitset is Jimmy the bitset, but flipped. And then same thing. Jimmy has been flipped using the bitwise not. If I do that. Okay. Cool. Uh-oh. Oh, wait. No, it's fine because I didn't input anything. So he's this, and the int value is 245, but then Jimmy's been flipped, and now he's 10. Poor Jimmy. Okay. Bitwise or. So we could do bitset input output, and then we'll do. What do we want first? Yeah, we will need a bitset. We'll do size 4 again. Just value initialize them for now. So it's that, and then we could do not. Oh, so we have that guy. It's called my bitset, and then we could say maybe unused int x my bitset. I'm just gonna do this to make sure this works. Okay, cool. Because it wasn't saying that I could just do this. Maybe unused. Cool. So that's fine. Do this int x, and he's gonna be position 4. And then what we're going to do is we're going to do my bit set, and we're going to flip position 4, or we're going to flip position, this will be is dead, and is dead in this byte is here. So he's going to go from being not dead to dead. So first we're going to say if my bit set test, right? Not test. Wait, isn't it? Hold on. Oh, if my bit set test is dead. If he's dead, we'll say he's dead. Oops. Okay. Otherwise, we won't. Actually, and then we'll just say else. Yep. Oh, didn't even have the insertion operator. That was stupid. He's alive. Oops. Okay. And then we'll flip him. Oh, hold on. My bit set. Oops, my bit. What's the easiest way? Can I do a space? Bit set? No, I can't. Damn, it's annoying. I'm just gonna kill this. Oops. My bit set is my bit set. Dot flip. And we're flipping the is dead. And now if, oops, my bit set if the value of is dead is false, then we'll say, or well, no, if it's true, he's dead, he's alive. Oh, same shit. This is the same logic. Well, we'll just type it out again. He's dead. Else, oops, he's alive. Uh-oh. Oh, this should be unsigned int. Can I do a uint 16t? Or oh, oops, yeah, 16t. What did how did I have it? Oh, oops. Uint 16t. And this part doesn't need to be unsigned then? Yeah, because we can't convert the just having trouble converting assigned to the unsigned. Let me find what that error was. We just said int conversion for, oh, okay, it's just warning because we're going from an int to size t. Oh, yeah. Converting an int into this, and this is a size t. Oh, well, this says an int, but this is a size. Yeah, see? Well, why does it say int right here? But then here it says it's a int 60 on int 64. Cool, now it's cool. Uh-oh. Out of range. Why? I don't want to be here. What if we do 64? Out of range. Invalid bitset position. Why? Oh, because we did 4. Yes, stop debugging. Now we're cool. Because I was using 4. I was thinking that this was an 8, so we'll do 8 this time. And then do 4. I was thinking that it was 8, and we were doing this one. Not these first 4, but the first and the next 4. But we were actually reaching outside of the bit. Or out of the bit set. So we were out of range. But now this is false at first because this value is false. This is 4 zeros. So this reads, please, like that. And at first, well, this is false. Is dead is false. Okay. Is dead is simply where it is. So we're taking a bunch of booleans and we're taking integers in order to represent the positions for the booleans. So if I want to access the boolean, I have to access the bit set that the boolean is stored in, and then get which position it is. Which of these booleans do we want? It's like a rack. Oh, hey, ma'am, did you order from your order's in cart 7? Let me get it. So let me go to the shelf called my bit set, and let me pull out cart 7, which would be this, or like shelf 7, I guess. Reach up to the tippy top. Get that 255 one, worth 128. Fail. So it at first here reads 0. So this value is false. It is unset or false or off. Okay. But then we flip it to be here. Cool. Okay. I've learned a good bit. Oh, it's true if either of true. Dude, let me see how cold this place is. Holy shit. It's actually getting cold. Hey. It do be cold. Oh, sit properly. Okay. If I was the truth, either are true. Okay. Hmm. Because right now that looks weird. Because this is multiple bits. It's like having. Oh. Oh. Pairs of bits. Dude. Actually cold. each pair of bits in the operand, so multiple pairs in operands. This looks really weird. This is this is multiple booleans. False, true, false, true, false, true, true, false. So how are we what are we comparing here? We're comparing the whole things? How does the whole thing evaluate? Do any binary bitwise operation by hand. Line up the two operands like this. What the fuck is going on? Apply the operation to each column of bits. Oh! To each pair in the operands. The pair being you and you, you and you, you and you, you and you. This or this. Oh, like what? Are they equal? Or okay, so we're doing or. Oh, so in this case we're doing like are they the exact same? Oh, so to what degree are they the same? In this case, they are 0, 1. Oh, well, to what degree are either of these true? I guess you could say. Well, you've got a false, a true, a true, a true. So 0, 1, 1, 1. They are 7 true, whatever that means. Okay. Second column. Yep. Is that in binary? So we're saying we're outputting that bit set or that bit set. So we're comparing these bits to those bits. Why? I don't know. If any of the bits in a column are 1, the result of that column is 1. Oh shit, it compares all of them, Wow. So and is probably pretty unlikely to be true for most. And so what is this for, like genetic sequencing or something? Where you're comparing how similar? Like, oh, humans can have this value can be this, this, or this. For this, they can be this, this, or this too. Oh wow, look at that. And they match up pretty well. 0, 1, 1, 1. Yeah, same. Okay, so we could do. I gotta go to the bathroom again soon. Need input and output. We're simply outputting a temporary bit set, size 4, initialized to be 1, 1, 1, 1. We'll just do 1, 1, 1, 1. Or standard bit set of 4 of 0, 0, 0, 0. Or standard bit set of 4 0, 1, 0, 1. Uh-oh, womp womp. So we're outputting the result of this. And the result of this should be 1, 1, 1, 1. It's not. Why not? OB? OB? Because it's a bit set? Okay. Like, what? So the OB tells that this is binary and I don't know. I don't really know. Okay. Oh, but if we did and oh, I like that we can click operators like this, or operators that are alone, or like little keyword kind of things. Like just clicking something will do it, so I don't have to go and then like select it. And so this and this and this, so it should only be, oh, it should be none. 0, 0, 0, 0, right? Yeah, because these are all false. So if any one of them is fully false, then they're all fully false. Because we put it up 0, 0, 0, 0, 0, 1, 0, 1, 1, 1, 1, 1. Well, which are all of them 1? None, because these are all false. Okay. Cool. Bitwise and is the same shit. Same shit. Zor. Oh, hell no. This or this, maybe it's important here. So it's an odd number. So here, yes, no, yes, no. Okay, so let's find that out. Oops. Assuming that these are both in the same hierarchy, they go by alphabetical. So we're just gonna output a bit set, and it is that, and then the fuck is the caret? I never use caret. Oops. Okay, and then we can do. Fuck, I can't do that. I mean, I could do that. Nah, I can't. Alright, I just have to select it with the mouse because it's an 80% keyboard. This, or this, or this, I guess. I don't even know how we say it. XOR. What? Bro, who? XOR? I guess. Bitwise XOR? So, among the operands, well, I mean, if it's left to right, then it's this and then this. So I think it's left to right. So we'll say, okay, no, yes, no. Basically, where is there an odd disagreement? So it's 0, 1, 0, 1. And then 0, 1, 0, 1. Oh, well, these are both the same. So isn't it 0, 0, 0, 0? Nope, hold on. Oh, because it's just checking. So we have odd here. So it's 1. And 1. Wait, what? Are you sure? That's an even number that's true. That's an even number that's true. That's an even number that's true. That's an even number. Hey, bro, are you sure? Oh, motherfucker, dude. I was about to say, it's like I lose the first one if I do that. So I have to do 0b. That's annoying, but whatever. Alright, remember, 0b for bit shit. Bitwise assignment operators, holy. Oh yeah, but you have to say, well, unless it gives you a warning. Oh, that. So shift equals and equals or equals? This and that. Save it, this or that. Oh, so I could compare these two and then set them to be their equivalents. So if we had we had okay, and then he is 1111 and then another one 0000 and then we yo oh I fucking stupid and then we say x and equals y. Like that? Yeah. So we're setting the variable to equal, we're setting this bit set to be the bit set of the AND operations evaluation or value calculation, I guess maybe something like that. No, we're not. Well, of the comparison, we're setting it to the comparison value. So we have 1111 000. Well, we know that AND requires both to be the same. None of them are the same, so it's 0, not the same, 0, not the same, 0, not the same, 0, not the same. Or not the same, 0, not the same, 0, not the same, 0, not the same, 0. So we know that the result is 000, which means this guy compared to this guy to see if he's AND is 000. But if we did the AND operator, what if we did XOR? Uh-oh, it doesn't exist. Oh wait, that's not XOR. What is that? Oh, that's the NOT operator. Whoops. That's XOR. It's 1111 because the differences are even. There's only one that's true. It's an odd number of truth amongst them. But if we do odd or, it's also the same. So the OR and the XOR are the same in this case. Oh, or we can set him to be the shift. So we can do bit set so we do and then we'll just call them 1111, sure, or oops, 0111 0b 1111. Then we could say output him, or we'll initialize him and then output him, and then we'll take him and then we'll shift him to the right by 3, and then oops, and then output him again. So do that. Oh, now it's 0 1 1 1. Oh, now it's 0 0 1 1. Oh, now it's 0 0 0 1. Oh. Okay. There's no bitwise not assignment operator, so I can't just flip them. You want to flip them? Oh, I could get not him and then flip them, but there's no bitwise not assignment. A not assignment being like a shift assignment, or what do we even call it? Shift assignment? Left shift assignment, right shift assignment, and or XOR assignment, but there's no not assignment. This is because, oh, but not as unary. Okay, yeah. So it can't operate on both. It can't set it because it operates on one and returns the result of one instead of both. So there's no side effect like normal assignment where it does it. But here there is a side effect. It returns, I'm assuming, bits and then assigns one to this. Or, well, sorry, it's right shift by one. So, boop. Integral promotion? How far are we? Almost there. Damn, long. Got a lot of shit. An integral type smaller than an int? They're converted. And the return type is that. Okay. So if they're unsigned shorts, they're given enough memory to actually function. Okay. Oh, well, yeah, they are width sensitive. So if it gave extra zeros before or after, then shifting it would be wrong. So if we had this guy, but then we implicitly converted him to this 32, then instead of it being 0, it adds a bunch of leading zeros to fill up the rest of the memory that it can hold, and then flips those two. So it gets this big 0 guy, puts this guy in there, and then flips him. Or instead, shifts him, but he's way bigger. So he shifts after he's made bigger, because this is bigger. We pass this value into there. Or we shift this guy and then pass him. Let's see. Yeah. Yeah, so we pass. Let's see. So we say not this guy and then that. Wait, that's interesting. It seems like this operator doesn't even operate first. It seems like C is put into this temporary bit set. So it should be a bunch of zeros and then this. But this gets, so that's what happens. And then this flips. Instead of it being flipping this first, 4 ones, 4 zeros, and then a bunch of leading zeros, it's actually leading zeros and then this, and then the flip happens after. Just like here, it should be a bunch of zeros and then this guy, and then we shift left 6. So it's a bunch of zeros, 4 ones, and then 6 zeros. But instead, or really what should happen is it gets shifted left 6 times. We should lose the first two, so it should be 1 1, a bunch of zeros, but instead it gets added first and then shifted, so these values are actually saved when they should have been lost. But then here, C neg. Oh, so if we have this uint and then we make them a bit set, that's 32, which is bigger than this guy, converts him, and then outputs him as this bit set. So if we tried to convert him back, hold on. That's interesting. Oh, because these operators operate and then return. I see. So we first need to static cast him. So bitwise operations are not happy when you don't have enough memory. And you don't have enough memory if you're shorter than, it looks like 16 maybe. Or maybe it depends on the implementation. Oh, yeah. So when we do this operation, this not operation, to flip this guy, it converts him to whatever size makes sense on the implementation. And then it has an issue because we're then assigning that value to a smaller one. Ow! Fuck, that hurt. Oh, then cast him back. Okay. So we could have bit set. We need iostream too. Oh, not necessarily. Just so we can see it. Alright, because aren't we seeing it? Yeah. Okay, so we'll have standard uint 8t, column x, and then column. So he's 8 bits, so he should be good for 8 then, right? And then if we're outputting a bit set that is size 16, we can output him. Hold on, let me get this fucking pimple really quick. Too cold, I'm turning the heat on. It's not. Go to the bathroom real quick. Oh, shit. Alright. That took way too long. Oops. Alright, let me... Oh, didn't know what that sound was. Forgot I was on campfire grind. Let me do this example really quick, and then I'm gonna pause the recording, make lunch. Need to cook some chicken, and I'll be good. And then I have all the shit for it now, because I had groceries yesterday. And then afterwards... I will wrap up the next, like, I don't know, 2.5 or 3 hours or something like that. Yo, please. It's too cold. I don't want to turn my heater on. Okay. So, we have this unsigned int, which is the same way of storing memory as a bitset, but a bitset maybe has some prepackaged stuff going on. If we first just output X, it outputs, it doesn't actually even, oh wait. Excuse me. Oh yeah, I forgot I can just comment shit out. Oh, it doesn't actually even print anything. What if I just put X to be 3? Oh, because it's doing it as a character. So, okay. So if we're doing this, and then we're printing it, I mean, this is basically making it printable, because otherwise it'll print as a character. So if we do this, and we do not X, yo, signed int. What is the conversion? Hold on, line 8 is the issue here. A not X? Oh, so it has a warning when we're doing that. So if we do not static cast to can I even do this? Or do I just do a static cast uint 16t like that? Oh, 64, really? So that's cool. And the nodding happens after. So we're casting this, nodding this, but printing the whole thing. But in reality, it's this is now a bigger bit set, and we're doing not the entire thing. What if I did static cast to a standard bit set of type, or with size 16, or actually, I don't need to do this. I could just do here, static cast to type bit set of 4. Fuck. I think I need to do that to make sure these operators are distinct. Maybe that doesn't work though. X? Oh wait, hold on. Here and here? Where? What are you expecting, bro? We're doing a static cast to a bit set of size 4. And we're casting X. Hmm? Wait, do we just cast it to whatever it already is? Really? There's no way. So you can't cast to a standard bit set, I guess. But you can cast to... But you can do a standard bit set of 16. To unt, unt16t, or unt8t x. And that's cool. And the reason why is because this value is normally an unsigned long, meaning a uint64. So instead, we're casting a value, so we're if we pass it the casted value, then it's cool. All right. And if we say it doesn't like that. Oh, it doesn't like it whenever we do bitwise operations on it. Because when it does a bitwise, it converts it to something and doesn't want to convert it back because this would be narrowing. So if we do static cast to a uint16 or a uint8 x, and we say not the whole thing, not static cast, and we okay, never mind. What? Oh, we can't say not the whole thing. We have to do the bitwise operation on it first and then cast it. I see. Oops. And so the point is that whenever we do bitwise operations on integral values that are smaller than the types that bit sets normally get, it converts those to be larger values. So when we assign things back after doing that, we get a narrowing conversion because we've implicitly converted smaller memory value to a larger memory value. And then when we try and assign that larger to another smaller, at first glance it looks okay because we're doing okay uint8t, uint8t, cool. But when we do this conversion to make it bigger, it's actually a uint8t to a 16t or a 64t and then back. So it's not okay. Okay. Our 32t here. So We have to cast it to an 8t. Please! Fucking hate that. Got stuck. Why was it stuck, bro? Just go under there. Fucking idiot. They're promoted and returned like that. So, if we pass it a uint8t, it's okay. But if we do an operation on that, the return value is whack. So what we have to do is take that return value and cast it to this. So if we did please I guess it's just a default type. I don't even have to do standard to get it. It's cool here. Bro. What fucking button was I pressing? Okay, function's closer. All right. If we do that, issue. Converting from an int to an unsigned int. Because we took this guy, did an operation, and now we are you would think it would return, but I guess it's not returning this type, it's just returning whatever type it did this to. So if we do that operation on this, if we do the not, the unary bitwise not, the unary bitwise not operation on this unsigned int 8t, which gets 8 bytes, or 8 bits, sorry. Well, the return value is not necessarily the same type. So we need to static cast to whatever type he is to get him back. Bro. Like that. Oh, okay, here we go. It wasn't cool because it saw this. It wasn't doing the entire, it was evaluating some part of this and then, I don't know. Okay. So basically, we have a guy. A little bit of memory. When we do something to him, the return type for this is larger memory. So, if we want to put him somewhere and use him, we have to cast him back down to what he was. So if we said 64, would this guy have been cool? I don't know. Bro! The fuck is that? I don't even know how we got there. Bro, what? Control Alt? How? How does it even happen? Control. Oh my god, it's going to the fucking website. Oh my god. Bro, what is it doing? Oh my god. Oh, we didn't even pass him anything yet. Okay, so the problem is the return type. So to fix him, we have to static cast to a uint 64. Well, whatever. We can cast him down to, I guess, whatever he was in the beginning. So he's an 8, so we do an 8. Cool. He's an 8, he's an 8. If we remove that cast part, there's an issue again because 2 uint 64. I still don't know why this is a uint 64, but it's not a big deal. Okay, they promote them. They're width sensitive. Yes, static cast. Static cast the result back to the narrower integral type before using to make sure the results are the same. Okay. To get rid of the leading zeros and shit. Alright. Avoid bit shifting on integral types smaller than int when possible. Okay. Yep. 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 Okay. What does this to this? Shift 2. So it's 0, 0, 0, 0, 1, 1, 0, 0, 0, 1. 0, 1, 1, 1. 0, 0, 0, 1. 0, 1, 0, 1. Okay, 0, 0, 0, 1. Oh, fuck. A bitwise rotation is like a... Dude, these are all the fucking questions I've seen before getting into coding, like on Leet Code and stuff. It'll explain some sort of paradigm or phenomenon and then tell you to do it and give you some bullshit to do it. Here it comes. A bitwise rotation is like a bitwise shift, except they're added back on. So that would go to 0, 0... Or hold on, wait, what? 0, 0... 0010, but you want it to be 0011. But a left rotate be that. Implement it, that does a left rotate. Okay. Okay, I don't like copying code. It's annoying. Okay, fuck off. Alright. I'm getting hungry. Alright. So we have a bit set. We have bits 1. Then we allocate output him rotated. Him rotate. So we're just rotating both, and a rotation is just by 1. So this would be... Okay, so this is just a rotate by 1. That does a left rotate. 1 left rotate. Okay. So this is the left rotate. So take bits. Hold on. It does a left rotate. set. Oh. What? What do I want test? So if it's left, rotate by 1. So if it was 1, 0, 0, 0, we want it to be 0, 0, 0, 1. If it was 0, 1, 1, 1, we would want it to be 1, 1, 1, 0. So do we only care if it's saving the ones because zeros are automatically added? So bits left shift by 1. Hold on. So we want to see what the left is. If the left is a 1, we want to save it. We want to rotate it and then save it. If not, so if bits test 3, which is the last position. So we'll just say int or un8t, and we'll call him left position 3. If the left position is 1, then so we have left position and then un8t right position. If it's 1, then bits left shift him by 1, and then bits set 3, or set 0, or set right position. No, bro. Oh, oops. We need 2 of these. We want. So what if I did that? Nice. Else return do I want to do that though? Return, I mean, I guess I could just do well, this is all one big operation, so let me return whatever, I'm just putting in parentheses because in this case we're gonna return bits that. So we have the left position and the right position. If the left position is set, this is how we get the value. Then we'll shift it left and then set the right position. If it's not set, then we're just going to return the shift. So we're going to output 10 and then 0011. Okay, that works. 10 0011. What's a better way of doing this? Especially because we haven't even learned to do, we haven't started doing these big code blocks. Are we even going to learn that? Compound statements? Maybe it is here. If statement, like if statement. Oh, here it is in blocks. I shouldn't even be doing that yet, I don't think. Because if we're doing this, I want to do this and then fuck, man, I don't want to do that this way. So this way works, or we could get the left position. Oh, okay. So we could just do a check here. We could do if bits test 3 to get the leftmost one. So, right, what were you even checking before? Oh, and I didn't even need to do this. I could have just said if that. Oops. What happened here? Oh. Oops. Hold on. Oops. Here we go. Now we're cool. All right. So that works now. I didn't need to say if it is 1 because it already is. All right. But here we could do if bits dot test and the leftmost position is 3 in this case because we're talking size 4. How would I find that out? Could I could do get size t and then set it, maybe size of. No, but size of isn't in bits, so I don't know. Oh, we could do that size. Isn't it where's size at? Size is the number of bits. So that should be 8. Okay. So we could say so we could get size bits dot size minus 1. So we have uint, just say uint8, and its left position is that. So it's 3 for this guy. And it would save, so we could say, could just do a uint16 just for the memory. And then we're not using him yet. Line 6 conversion. Oh, hold on. From size t to that. So I could static cast it, I guess. To a uint 16t. Oops. That. So we'll cast the size to be this. That way we have at least 16 bits worth of size. So this would work all the way up to a 16 size bit set. And then we'd say if bits test left position. So that tells you this should be, so it's a static cast of bit size. Okay. So we have bit size, who's static casted to an unsigned int t. This is the size. -1 will give us the left position. If this is 1, so if, we could say if not this, then return bits left shifted by 1. If it is set, oh, well, we don't even need an else. We could just do return. So if this isn't set, then just shift it. But if it is set, then we're going to shift bits and then we're going to set the last one. And then I think we could just return that. Hold it. Line 6, issue where, why? So we're from an int to oh, hold on. So we don't want this. We want bit size -1 yeah. We don't want to right here what was happening is we were taking bit size, casting it to an unsigned int, and then subtracting 1, which is an int, which then I think was doing integer subtraction. Oops, sorry. Instead, we want to take the bit size, subtract 1 first to get the leftmost. And then, so if it was a 1-bit guy and we shifted him, then he would stay 1. And it can't be a negative size, so we subtract 1 from the size. And then we cast that, and then we get it. So in this case, it works. That makes me happy. So in this case, we are using size. Are we even using test? We are. So we're saying this is the left position so that it works for even a 16 now. Oops, hold on. Where did that get wonk? Oops, here we go. Uh-oh. Oops, here we go. So, taking this guy, and he's shifted. So it's, this guy goes to the end, so it should be 001, and then a 1 at the end. This guy should be 101, and then a 1 at the end. Let's fucking go, baby. Cool. So that works. But don't use the test and set functions. Use bitwise operators. Okay. I was using both. Am I doing something redundant here? So we're not using size or that or test? We're just setting it and then and the bitwise operators are wait, is it really? Bro. We're good. Just couldn't breathe right. Okay, so that's one way of doing it. But another way, I don't want to check the first solution because then it'll give me a hint for the next because I probably did it a different way. So I want to rotate him. So we want to shift him, but then set the end. I mean, I guess I could just do that, right? Couldn't I just shift him and then set the end? And then, but how do I shift the end? Do I... So I could flip one. What are the operators again? What do I even have access to? That's it? Really? Hmm. Excuse me, any bit shifted off or added onto the other end. So shifting isn't enough. Flipping each isn't enough. Oh. So if I take this guy and I shift him 0, 1, 0, 0. And then I set him to be, so if I take a temporary variable and I shift him, and then I set the main one, and then I return the OR of the two of them, then that should work, shouldn't it? Isn't that the best way of doing it? So we could say bits temp is bits shift. So hold on. Bits shifted is bits is initialized to be bits shifted by some amount. So we could say int we could say just int shift amount is 1 for now, and we'll shift it shift amount. And then we return bits or bits shifted. No, bro. Oh, oops, sorry. Bit set for, or we could say int bit size is bit.size. Int bit set or oops, sorry. Return bits or bits shifted. Uh-oh. Oh, maybe it's here. So what if we just say 4? Bits shifted. Shift amount is 1. So what if we say const uint 8t is fine? Okay. What if it was a 64? I'm just curious. Oh, okay. Alright. So we just need it to be a uint, basically. What if it was just a uint? Oh, oops. That doesn't exist. That'd be fine. Okay. What if it was just... Okay. Alright, so we'll just make this const expression because it's known. I'm gonna put it here. So we first just initialize them to be whatever. Well, it could just be... Just make this a uint for now. And we'll make it be bits.size. The problem is Oh, because that could be a 64, I think, size T. Yeah, that's correct. And we can static cast to a uint 16T bit size. Oh, hold on, this is fucked up. Wait, what happened? Shift amount. We don't even know what the shift amount is. This is the size. So this is just be an amount that we choose. And it's not happy with 1, I'm guessing. Oh, it is happy with 1. Okay. So we'll shift it to shift amount. Then and this would just be bit size. Or oh, hold on, bit size. And the size and bit size is bits size minus 1 statically casted. But the issue is on 8 because cannot convert. This needs to be known, I think. Fuck. Alright, it's fine. We'll say 4. Hold on. Oh, oops. Hold on. So that's not the answer. So if we shift it over by 1, then we'll have extra stuff. So we could say, what is crusty here? I'm getting hungry. So if we shifted him and we want to return, or hold on, we shift him to this guy, but then shift this guy to be this guy. How do we use bitwise operators to do the rotation? Not shift, the rotation. So we can't do or, because otherwise it'd be 1, 0, 1, 1 here. Because there's a 1 and a 0, so it's a 1 there. We could do or we could do and would only return 0, 0, 0, 1. So I need to shift them. Fuck, man, I'm too hungry. feel my brain not working. Is it shift and then return the OR? The XOR? If I shift them and we return OR, so if we shift him over by one, it's 0, 0, 1, 0. Like here that would work because there's no offset. So the case, this is really the case I need to pay attention to fix. So we want the first to be, want the first to not be added, so we can shift them first. Do I write it out? I guess I could. And we want so if I shift him, or if I just shift him, look at that. How do I not capture this guy, but capture this guy? I mean, I could shift him his length to the right. I could shift him his length -1 to the right. To put whatever, to kill everything except the first one. So I could shift them to the left, and then shift them to the right, and then OR them. So I could shift them to the left 1 to get that. Or I could shift them to the right, size -1. Because the size is 4. So I could shift them to the right. Size -1. Which in this case would be 3. Because this is 4. So we go 1, 2, 3. Which would yield 0, shifted, shifted, shifted. That, right? And then we could do or return this guy or this guy. That's one way. Let me confirm. So if we get the size, so we get we'll get so we could say bits shifted left. But then this is only for one. Will I be able to do it for multiple? How would I do it for multiple? Would it work? So if I wanted to shift left, or well, I mean, it'll be magic numbers for now. Because I can't think of anything else. So we'll have temp bits. And that is bits shifted left by 1. Or no, we don't want to. Shift left by 1. And then, or so we have left shifted bits, right shifted bits, right shift by bits size -1. It's bits shifted to the right, size -1. And then we return left shift, bro. Oh my god, I didn't fucking make it. Bit set. Turn left shifted bits, right shifted bits. Fuck yeah. So that's one way. So we shift it to the left by 1. We shift it to the right, whatever the size is. I mean, so we could say this works, right? For any size, couldn't we? Okay, so we could say, oh, fuck you. Let's just say we have 0, 0, 0, or let's just say we have 1, 0, 1, 0, 0, 1, 0, 1. Like that. And we want 0, 1, 0, 0, 1, 0, 1, 1. So we left shift him 1 time. So we get 0, 0, or hold on, wait. We get 0, 1, 0, 0, 1, 0, 1, 0. And we right shift size -1. Size in this case is 8. which means this whole thing is 7. Right shift him 7 times. So 1, 2. So we get this guy loses, and now he's here, and then he loses. So we basically just move everything over 7. So we lose. We get 1, 2, 3, 4, 5, 6, 7. So we end up getting 7 on the right. So we get 0, 0, 0, 0, 0, 0, 0, 1. And then this guy, or this guy. So we get 0, 1, 0, 0, 1, 0, 1, 1. So we get 0, 1, 0, 0, 1, 0, 1, 1. So this works for a single shift. And the only reason that works is because I'm trying to figure out for a left shift, who is here? Or sorry, who is here? And I get him by shifting everything to the right. To 7. To find out what he is. So I find this guy out by doing this, and I find out where he is. It'd be so much more convenient if I could just do bits. This guy is bits. Zero B, whatever. If I could just do bits dot size, or not size, bits test, or so I could have last position, and it would be all the yeah, and it would be size of bits, or it would be bits.size -1. Or hold on, wait. This is where my brain fucks up as I'm hungry. So actually we want to check the first position. So we say first position, last position, excuse me, and then we do one thing for a left shift, or a left rotate, and another for a right rotate. The first position is bits test what is it? So size -1. So we'll do hold on. First position is bits.test, or oh, it's size -1. Okay, yeah. So it's first position is bits dot size -1. Last is 0. And what we would do is we would get bits dot test first position, and then do the same for last position, and then we could shift and then add the first to the last. If we're doing a left rotate to the left, we're losing the first guy, so we save him somewhere. We do the rotate to the left, and then we tack him onto the back. So we rotate these guys, and we tack him on right there. And if we were doing a right rotate, then we save the last position somewhere. So we would save whatever, 1 in this case somewhere. So we get 1. And then we do the right rotation by 1. Do the right rotation by 1 to get this. And then we pop him to the end. Or, sorry, we get the last position. Yeah, we get the last position, and then we do the right rotate by 1. Which means we lost the first guy, and then we go and we pop this guy here on the first. Okay, don't need to save. Okay. I need water. Yeah, I want to fix this first before I get food, so I'm gonna get water first. Yo! So for now, this works. Heating up my stovetop. So then I can eat, and then I'll come back and then probably fix this maybe. So we could make 2 other bit sets. Have one be shifted left, however many times, I guess. Shift them out. Maybe, does that work? Shift them out by 1. So if we're doing a shift them out times a bunch, we still only care about the first and the last, I think. No, because we could be losing multiple. If we shift 1, we only lose 1, but if we do that, we need to save multiple. In this case, we're only doing 1 left shift, so we only care about the leftmost one. So we'll do 2 things. We'll get the shifted version, and it will not have wrapped and put the leftmost bit on the rightmost side, on the right side, the left bit on the right side. And then we do a different one, which is shifted to the right as many times as it takes to put the left bit on the right side. And then we do the OR, because they should only differ by that 1 bit on the end. Well, no, hold on. The only thing they should have in common would be the right bit. Actually, it's because the left bit is missing it, so we tack it on by giving him another thing of bits that is all 0 unset or off, whatever, and 1 that's correct. Nah, it's not that important. Okay. Well, hold on. I did it without using test and set. Bro, that's exactly it. It's just, we didn't, I could have just returned it like this. Why did I want to save it? Do I even need to do that? Well, this is a better way of doing that. What we could do, I didn't optimize it enough. I didn't realize that I could have just removed them from the beginning, because this is just shifting it. I forget this isn't assigning anything. This is just showing you what it would look like if it was shifted. So we shift it, and then shift it all the way to the right. This is such a terrible way of doing it, though, in my opinion. Like for 3, I mean, I guess not, because if we're only dealing with 4-bit things, we know we're just going to put it to the 3. We know we're probably not going to pass this. Well, but what if we want to rotate bigger groups. I don't know. I mean, maybe what we would do is we would pass smaller ones. I don't know. Not sure. All right, well, we did it. Fucking did it, baby. That was it. It just wasn't perfectly optimal. Why? Was there any reason that I might want to keep them like that? 2 different bit sets just for this instead of just comparing. Well, I mean, I guess, like, if I could, this gets rid of magic numbers. These aren't necessarily magic numbers. And we're just saying that we're just saying shifts left, shifts left by 1, and returns left rotated. So this whole function returns left rotated bit sequence. Shift left by 1, shift right, however big. Okay, so this works with multiple sizes, but not multiple rotations, not multiple shift. You can only shift by 1. But we could do it with bigger sizes, because otherwise 3 wouldn't work for another size. I'll take it. My solution's better. But it was also worse because it wasn't as optimal. Shift right, however big sequence is. Shift right to put leftmost value lost during left shift in the rightmost slot. Bitwise or returns left shift, the left shift with the right shift, while keeping shift lost value. Okay, fuck it, bro. That worked. Whew. I was thinking that the solution was going to be so simple. Bit masks. All right, we'll continue this in a bit. I gotta eat.